So this is what a compound inequality looks like. It is made by two inequalities, which can be unified by a or an and. In this inequality, we need to solve first this one and then this one. So that's what we're going to do. The first thing you have to do is to put all the constants in one side and all the variables in the other. So we get here we subtract 7 in both sides and we get 20 and 5 times c. So we divide and we get c is less than 4. Now we move on to the next inequality. In this inequality, we do have a negative in the variable side. So what is going to happen is that we're going to divide it out in both sides. So we have here an 18 over minus 3 and a z in this side. But as you can see, the sign changes to the other side. So we get a z is greater or equal than minus 6. Something you have to remember is that the sign only changes when you have to divide or multiply by a negative. It doesn't change when you subtract or add a number, just when you divide or multiply. So moving on, we get these two answers, which are both right, and they too are valid. So what we need to write is write them both and write an or, because they are both true. We can represent them in the number line. It can be greater equal than minus 6 or less than 4, which is the whole number line. As you can see, there's an arrow going to the left and an arrow going to the right, so this is the whole number line. And the solution as an inequality is from minus infinity to infinity. One last thing you need to know about the inequalities using OR is that if you had a number line that you did not have anything in between, it would be both answers are right, both our answers are valid. So if, let's imagine that this does not exist, that the 4 is actually z is greater than 4, and that z is less or equal than 6, then you would have this answer, which is represented with a u, that is the final answer. In this case, we're having an and between our two inequalities. We're first going to solve this. We subtract 2 y's from both sides and we subtract a 7 in both sides. So we end up with y is less than minus 7. And then the second inequality, we subtract 8 in both sides and we end up with 4y is greater than minus 56. We divide out the 4 and we end up with y is greater than minus 14. These are our inequalities. If we put them together, we get this. This y satisfies both inequalities. and can be represented as the union or the numbers between -14 and -7. So the numbers that qualify to be the y are all the numbers from -14 to -7. The important lessons you need to know about linear compound inequalities are: when multiplying and dividing by a negative number, the inequality symbol should be flipped. In an OR, the solution is the union of all individual solutions. In an AND, the solution is the interval of all individual solutions.